All right, today we're going to talk about finding a polynomial equation when the roots are given. So let's start with quadratics. So if you had a quadratic equation whose roots are 5 and 3, this is sort of like working backwards now. Normally I give you the equation and I ask you for the answers, but now we're going to work backwards. I'm giving you the answers and I want you to write the equation. So what this equation is saying is that x equals 5 or x equals 3. Those are your x-intercepts. So if 5 and 3 are your roots, then x minus 5 and x minus 3 are factors. All you have to do now is multiply this out, and you'll get the quadratic equation whose roots are 5 and 3. Please note that when we're talking about finding a quadratic equation, there are two important things that have to be in your answer. One of them is that it has to equal 0, and that the coefficients should be relatively prime. That means there are no greatest common factors that can be taken out. For instance, if this was 2x squared minus 16x plus 30, you would have had to divide out the 2 to get the integers to be relatively prime. That's something that students tend to forget, so star that in your notes. And it also has to be integers. All right, so let's find a quadratic equation whose roots are 2/3 and -1/2. I always start these the same way. I start by saying x equals 2/3 or x equals -1/2. Now again, we're kind of working backwards, so those became fractions because I divided. So now I'm going to do the opposite. I'm going to multiply. So I'm going to multiply through by 3 and by 2 after I go ahead and put it in its factors. So here it's in its factors, and then I'm going to multiply the first parentheses by 3 and the second parentheses by 2. Now all I have to do is multiply it out, make sure that there are no common factors I can take out, and make sure that the equation is set to 0. All right, find a quadratic equation whose roots are plus or minus 4 square root of 2. Again, always start the same way. Start by saying x equals plus or minus 4 square root of 2. Now, where did that plus or minus come from when you were solving? Well, it comes from square rooting, but I'm working backwards, so instead of square rooting, I'm going to square. So I'm going to square both sides. Remember, 4 square root of 2 is 4 squared, which is 16, and then the square root of 2 times the square root of 2, which is 2. 16 times 2 is 32. And then to get the equation equal to 0, I'm just going to subtract 32. All right. Find a quadratic equation whose roots are plus or minus 5i. The fact that it has an I in the answer here doesn't change our process at all. We'll say x equals plus or minus 5i. The plus or minus came from square rooting, so I'm going to square. When I square this, I'm going to get 25i squared, but remember that I squared is -1. So this will become x squared equals -25, and I'm going to add the 25 and set it equal to 0. All right, find a quadratic equation whose roots are 3 plus or minus 2 square root of 5. Again, I start by setting it equal to x. Now I want to get the term that has the plus or minus with it alone, so I'm going to subtract the 3 first. Now I can square both sides. I'm going to expand the x minus 3 squared, and I'm going to subtract the 20. And now I have an equation whose roots are 3 plus or minus 2 square root of 5. You can always prove that by taking this equation and solving it and making sure that that is in fact what you get as an answer. Find a quadratic equation whose roots are 1 plus or minus 3 over 2i. Again, not going to really do this any differently. I'm going to multiply by 2 to get rid of those fractions. I'm going to subtract the 1. I'm going to square both sides. I'm going to expand both of those polynomial on the left and on the right. So now on the left, 2x minus 1 squared, remember, that's like saying 2x minus 1 times 2x minus 1. So I'll get 4x squared minus 4x plus 1. And on the right-hand side, when you square 3i, remember you have to square the 3 and the I. So you'll get 9i squared, which is negative 9. Now all you have to do is add the 9. But what do you notice about this particular quadratic? Right? You can divide everything by 2, so those coefficients are not relatively prime. So your final answer should be 2x squared minus 2x plus 5. All right, find a third degree equation whose roots are 4, negative 3, and 2/5. So again, start by saying x equals 4, x equals negative 3, x equals 2/5. Now you're going to put those roots into their factors. So x minus 4, x plus 3, and then again if you multiply through by 5 and subtract the 2, you'll get 5x minus 2. To multiply this together, I would multiply x minus 4 times x plus 3 together first, and then go ahead and expand the rest of it. Find a cubic equation whose roots are 4 and minus 1 plus or minus square root of 5. Again, the 4 is not really a problem. I know that that's x minus 4. And here when I have negative 1 plus or minus the square root of 5, I'm going to add the 1 over. I'm going to square both sides, expand that polynomial, and then subtract the 5. Then I'm going to have to put those two together and multiply it out. And a fourth degree equation. So again, start with this one, x equals plus or minus the square root of 3, square both sides, subtract the 3. There's your first factor. Going to say x equals plus or minus 4i. You're going to then square both sides and add the 16, and then multiply those two together.